Hello students, welcome back to the 8th video of this playlist. So in this video, we will be solving question number 8 from the most recent past paper of Statistics 1, which is the October 2024 S1 paper. So let's see what's the question number 8 from this paper is about. So this is question number 8. So let's get started with question number 8. So question number 8 says an orchard produces apples. Okay, the weights A grams of its apples are normally distributed with mean mu grams and standard deviation sigma grams. Okay, so it is known that probability of A less than 162, this is equals to 0.1, and probability of A greater than 162 and less than 175, this is what, 0.7508. So these are the two probabilities given. We don't know the mean of the weight. Okay, we also don't know the standard deviation of the weight. Fine. So part A is here asking to calculate the value of mu, the mean, and the value of sigma, that is the standard deviation. Okay, so the two probabilities are given, so we will use these two probabilities to figure out the value for the mean and the standard deviation. Okay, so for part A, at first consider the first probability that is given, which is probability of A less than 162, this is equals 0.1. So at first what we will do, we have to standardize the data. Okay, so the formula for standardization of data, it is what, z, that is z equals to what, A minus the mean, A is the data, actual data, minus the mean of the data, over the standard deviation, right? So why do we standardize the data in standard deviation, sorry, in the normal distribution? Because we can compare it with the bell curve. Okay, in the bell curve, for a normally distributed data, in the bell curve the mean is always at where, 0. The mean is always at where, 0. Okay, so as you subtract the mean from the original data, okay, you can compare it with the what, bell curve. You can compare the distribution of the data with the what, bell curve. Okay, that is why standardization of the data is significant in normal distribution. Okay, so we know that A is what, A is distributed normally with mean, mu, and the sigma square is the variance. Okay, so probability of A less than 162, so let's standardize that data. So z less than or equal, right, since it is normally distributed, so for normally distributed data, less than or equal and less than or equal and just less than, both are same because these are continuous data. Okay, so 162 minus the mu over the sigma, this is equals how much, 0.1. Okay, okay, so if it is less than, if it is 0.1, then what does it mean? Look, have a look on it. Let's have a look on the bell curve. Okay, this is basically use of symmetry. In the bell curve we can have the use of symmetry. Less than or equal 162 minus mu over sigma, this is what, 0.1, which is less than 0.5, which is less than half of the probability, right? Because the sum of the total probability of a bell curve, that is the area under the bell curve, it is what, 1, right? So 0.1, it's less than 0.5, that means this is what, this is basically this region, right? So this region, it's what, negative. In this region the standard value is what, negative, right? And in that region, using symmetry, we can say that the same area lies here. Okay, This area, it's what? This standard value is what? Positive. Okay, this standard value is what? Positive. Okay, so what we can deduce from here? The probability is what? 0.1. So this is what? Greater than that standard value. Okay, greater than this standard value is what? 0.1. This part is 0.1. Okay, so uh, we will use the normal distribution table that is given at the last. Okay, that is given, that will be given in the formula booklet. Okay, we will use this one. So this distribution table, this is percentage distribution table. It shows probability of z greater than or equal d. Okay, so for that we need what? Probability is 0.1. Greater than that is what? 0.1. So which probability is 0.1? Here you go. It is already marked because we had similar type of question earlier. So this is 1.2816, right? The value for z is what? 1.2816. Okay, so that would be what? 1.28. Okay, this is not the value. 1.2816. Okay, so 162 minus mu over the sigma. Sigma is equals to what? Positive. We got the positive value is 1.2816. So the negative value would be negative 1.2816, isn't it? Using symmetry, right? Okay, so this is what? Negative 1.2816. Okay, now cross multiply and make an equation in terms of sigma and what? Mu. So 162 minus mu equals to what? Negative 1.2816 sigma. Okay, so what you will get? Take mu to the right side. So mu minus 1.2816 sigma, this is equals to what? 162. This is the first equation. Okay. Okay, now the second probability equation. This is what? A greater than 162 less than 175. This is what? 0.7502. Okay, so we will use this one now. So we will standardize it as like as before. Okay, z greater than or equal, this is how much? 162 minus mu over the sigma. Okay, less than or equal what? 175 minus mu over the sigma. Okay, this is equal to 0. What? 7508, right? Okay, sorry. So how can we use this probability? Look, again, the use of bell curve. Okay, for using the bell curve, let's consider another clear bell curve. For okay, it should be solid line. Okay, so here you go. This is the bell curve. Okay, it goes like this. Okay, the mean is right at the middle. The median mean for normal distribution all lies at the middle. Okay, okay, so z greater than or equal 162 minus mu over sigma, and less than or equal what? 175 minus mu over sigma. This is what? 0.7502, which is greater than 0.5. That means we can imagine this region is basically you can say, just assume from here to there. Okay, okay, so this, let me mark it out. This region is 0.7502. Okay, this region. Okay, so if this region is 0.7502, so if you subtract 1 from there, if you subtract 0.7508 from 1, what you will get? Okay, just hold a bit. Okay, less than 0. Okay, less than what? 162 is 0.1. Okay, this probability is known to us. Okay, 162 we already know that it lies in the negative part, negative, that is left of the mu, left of the median, right? This is 0, so it lies on the negative axis, right? So this is what? 162. This is the standard value for 162. So we already know that this area is basically 0.1 from the previous probability, right? Okay, so let's consider. We can say what? Probability of z less than or equal 175 minus what? Mu, sorry, sigma over the mu. This is equals to what? This is which region? Can we say this is basically this 0.1 plus this 0.7508. Make sense? This is one. This is the standard value for one. This is the standard value for 162. So less than that is 0.1. It's given in the question, and this area, the yellow marked area, this is what? 0.7508. So what we can say 0.8508. Okay. So since it is greater than 0.5, that means it is what? Exactly here. The standard value for 175. Okay, so let's use what? The standard data value, the probability distribution table for normal distribution. So we got the probability is 0.8508, right? 0.8508. 8508. It's there. Have a look. 8508. So its standard value is what? 1.04. Okay, it's what? 1.04, and it will be positive because it lies to the right of the what? 0. That is the median. Okay, so what we can write? 175 minus mu, 175 minus mu over the sigma. This is equals to what? This equals 1 point, what we got there? Yellow marked 1.04. Okay, this is what we got, 1.04. Okay, this is 1.04. Now form an equation. What you will get? 175 minus mu equals to 1.04 sigma. Okay, so mu plus 1.04 sigma, that would be what? 175. Okay, so now we need to just solve the two simultaneous equations. The previous one we got mu minus 1.2816 sigma. Okay, mu minus 1.2816 sigma, this is equals to 162. Okay, so just use elimination method. Okay, so you will get mu plus 1.04 sigma, this is equals to 175. Okay, now what we can do, from the first one we can subtract the second one. Okay, so mu cancels out, so you will get negative what? 1.2816 plus, okay, negative 1.2816 minus 1.04, that is basically negative 2.3216 sigma. Okay, this is equals to 162 minus 175, this is basically negative what? 13. Okay, so the value for sigma, the standard deviation, this is what? 13 over 2.3216. Negative negative cancels out, so 8125 over what? 1451. Okay, and the value for mu you will get here in exact form, that would be 162 plus 162 plus 1.2816 times the sigma, which is 8125 over 1451. Okay, so 8125 over 1451 times 1.2816 plus 162. that would give you 169.17643. Okay, so up to 3 significant figures, if you round to 3 significant figures, you will get mean. This is 169. Okay, and the standard deviation, this is 8125 over 1451, which gives us 5.60 up to 3 significant figures. That's what we got the value for mu and the value for sigma. That's what part A of question number 8 has asked for. Fine. Okay, next is part B. In part B, the question says a second orchard also produces what? Apples. The weights B grams of its apples have distribution. B is distributed normally with mean 215 and standard variance is 10 squared. An outlier is a value that is greater than Q3 plus 1.5 times the IQR, the interquartile range, or smaller than Q1 minus 1.5 of what? The IQR interquartile range. An apple is selected at random from the second orchard using the upper quartile Q3 221.74 grams. Part B is asking to find the probability that this apple is an outlier. Okay, so for finding the probability that this apple is an outlier, we need to get the limits for the outlier at first, the value for the limits. Okay, so for that, Q3 is known, that means we need to figure out the Q1. Okay, so for finding out Q1, what we know, look, for part B, what we can say, for Q1, what we can say, probability of B less than what? Q1 is equals to what? 0.25, right? So now standardize probability of what? Let's say, wait, I wrote it opposite. Basically, it should be Q1 less than, let's say, X. Okay, this is what? 0.25. Okay, so what you will get here, okay, earlier one was fine. Okay, if we would write B what? Less than Q1, it's perfect. Okay, so now if you standardize, what you will get? Less than or equal. It's just like representation, so not a big deal. Okay, Q1 minus, what was the mean? The mean for B, distribution of B, it's what? The mean is 215. Okay, it's 215 over what? The standard deviation is 10, right? This is equals to what? 0.25. Okay, so let's use what? Let me describe you using what? The bell curve. Which part is this? So this part goes like here. This is the bell curve. The middle region is what? The mean, isn't it? Okay, so less than that part is 0.25. This means this region, and we can use symmetry to say that this region and that region is what? Similar. Okay, so use the percentage table to get the greater than area, the top part. Okay, this is 0.25, probability 0.25, which goes to 0.025 is there, 0.25 is not given there, but you can use the what? This table. We need greater than what? The value greater than Q1, it's what? 0.75, or you can say 0.25. Okay, 0.25 should be greater than, so less than that is 0.75. Okay, so 0.75. Okay, you can consider this one 0.75. It's basically 0.7486, and this is 0.7517. So which one is closest to 0.75? It's 14. Difference is 14. Its difference is 17. So this one, take this one. Okay. So you can take more accurately if you have the class with FX991EX calculator. You can go to distribution and then go for inverse normal. Okay. So we need 0.25 area. Is it 0.25? No, it's basically 0.75 area. Okay, the area under the the bell curve. So that is basically giving 0.6744 something. Okay, so 0.67, it's perfect, no problem. I just checked out the value using the calculator. Okay, so that would give you the value for standard value for Z. This is what? 0.67. Okay, so now what we will get the value for Q1, the lower quartile. It is basically 0.67 times 10 plus 215. This is basically 221.7. Okay, this is basically what? Q1. So we got the Q1, isn't it? So now we can find out the limits, right? The upper limit and the lower limit for the outliers, right? Okay, 221.74 there. Okay, we got 221.7. Oh, sorry, that should be negative. Okay, that's why I got the Q3 instead of Q1. So this should be negative 0.67. Okay, now calculate it, please. So that would be negative 0.67 times what? 10. So 215 minus 0.67 times 10. That is basically 208.3. 208.3. This is the what? Lower quartile. Okay. So we got the lower quartile 208.3. Now find out the IQR, the interquartile range. So Q3 minus Q1, that would be what? 200. It's given as 221.74, right? Yeah, 221.74 minus 208.3, right? So 208.3. Okay, so that would give us what? 221.74 minus 208.3. This is basically 13.44. Okay. So we will just find out the probability of B getting less than what? Q1. Q1 was 208.3 minus 1.5 times 13 point what? 44. Okay. Plus what? Plus the probability of B greater than 221.74 plus 1.5 times 13.44. Okay, this is the probability of getting an outlier. Okay, so these two should be added. Okay, so this is what? This is the probability of outlier. Okay, this is equals to that. Okay, so probability of outlier, that would be what? This is equals to how much? So we can calculate it how? Standardized, isn't it? Z less than or equal, let's calculate it out at first. 13.44 times 1.5, so 208.3 minus that, it is basically 188.14. Okay, 188.14 minus the mean. The mean is how much? the mean is 215, if I'm not wrong. This is 215 exactly. Okay, 215 divide sigma. Sigma is how much? 10. Okay, this one plus probability of z greater than or equal what 1.5 times 13.44 plus 221.74, that would give us 241.9. so standardizing, we get 200 minus 215 over 10. Okay, now let's use the bell curve to understand the probability. Okay, so if you use the bell curve, what you would see here, okay, the mean is right at the middle, right? Okay, so outlier is what? It is basically forming a symmetrical region. Consider this is the Q1 and this is what? Q3. This is what? Q1, this is Q3, and this is basically 0. So outlier is Q1 less than the equidistant, right? This should be equidistant. This is the lower limit for the outlier and this is the upper limit for the outlier, because this region should be equal, because they are equidistant. 1.5 times 13.44 less than, one is less than, the other one is what? Greater than. So this region are equidistant, right? Equal. So basically we want this area, these two area. So these are symmetrical. So this is what? If you just get the probability of one of them and multiply it by 2, you are getting the answer. That's it. So probability, let's consider 2 times of probability of what? Z greater than or equal, we will get 241.9 minus 215 over 10. This is basically 2.69. 2.69. Okay, so this is equals to 2 times what? 1 minus, we need the less than, because in order to get the less than, in order to use the probabilities from the table, we need to represent it in the form of what? Less than. So less than or equal what? 2.69. Okay, now we can use the distribution table. Less than or equal 2.69. okay, less than or equal 2.69. Where is 2.69? 2.69, basically it's given 2.7. okay, it's given 2.70. so 2.69, you can take 0.9965, it will be accepted, but if you have the calculator, that's better. We need normal cumulative distribution, so it's coming from where? Okay, negative infinity. The upper limit is what? 2.69, what I said, right? Let me check it out whether 0.9953 is perfect to be taken or not. This gives 0.9964. Yeah, you can take 0.9964, no problem. So 0.99, so this is what? 2 times 1 minus what? 0.9964. okay, so what would be the value you will get here? Okay, 1 minus 0.9964 times 2, this is basically 0.0072. okay, this is 0.0072. so 3 significant figures, it's not possible here, but we can give to 3 decimal places, right? Or you can keep it in this form, 0.0000072. That's perfect. Okay, okay, what's the front page says? Should we give to 3 decimal place or 2 significant figures? inexact answer should be given to 3 significant figures. Okay, so 3 significant figures is not, it's not possible, so we will consider what, 0.0072. Fine. Or we can consider like what's the least number of significant figures considered in the question. They have considered 2 decimal places, 5 significant figures, right? So we can say 0. Okay, 2 decimal places they considered, 4 decimal place they have considered there. Okay, so maximum 4 decimal places there. So up to 4 decimal place we can consider 4 decimal place. So if it is 4 decimal place, 0.0072, this is correct, no problem. Okay, so that was all about question number 8. I took longer time to explain question number 8 because most of the students has problem in the normal distribution part, so I have tried to explain as much as possible in question number 8, the last question of this recent S1 paper. So hope you all understood, and thank you so much for watching the videos. Thank you. Fine.